Thank you everyone for joining us for this webinar, Why Does My Console Do That? A brief tour of lighting control history with Rob Halliday. My name is Michael Grandinetti, and I'm a content marketing coordinator here at Harman. A few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a Q&A function where you can submit questions to the presenter, and he will try to answer as many questions as possible at the end. This webinar will also be recorded, and the link will be made available a few days after the presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we encourage you to take a look at the different webinars in our Learning Sessions workshop series on pro.harman.com, as well as by visiting Harman Professional Training to see our many on-demand and certification courses that are available to you for free. And now I would like to introduce to you the presenter for today's webinar. Rob works around the world usually as a lighting designer and programmer. His use of the latest lighting technology on shows is balanced by fascination with the history of show lighting, reflected in his monthly Classic Gear column and in the UK's Backstage Heritage Collection, which he helped create. And now I'll pass it over to you, Rob.
So you should expect the tumultuous applause, but we don't get any of that. Also, everyone's microphone is muted except mine, so I just get to talk at all of you. Hello. Well, there we go, PowerPoint. So, yes, I wear many hats, as I think you got from that introduction. I do shows, I work with lots of people, I light shows on my own sometimes, I program shows for other people. I get to use stuff, grew up with stuff that felt new at the time, but now probably is all classics in itself. And I also have this sort of interest in old stuff, in the stuff that shaped where we are now with technology, sort of fascination with our history, if you like. Some part of it is just sort of practical, morbid curiosity. So, for example, how did this on the left, which was the most advanced lighting console of its day, 1976, how did that end up looking like this on the right, which is sort of this pile of scrap leftover bits? Why did that happen? On a more practical level, it sort of seems to me, and this is where this sort of came from, when we started talking through ideas with Brad, it's about not just a sort of boring, orderly history of lighting control, but it's this realization that lots of functions you find on a current lighting desk actually owe something to a previous generation or a generation before or way back, or sometimes even to times before electricity. And it was sort of trying, I guess, stitch some of that history together. Doesn't matter, but sometimes it's interesting to know why this, very simple looking button on your current console owes something to a machine from 50 or 70 or 100 years ago. And sometimes, if you understand why it was created, you have a better understanding of the weird, quirky way it might still work now. So I thought we might try and look at that. And as part of that, there are functions which have carried through years and years and years and years, but there are also some which have got lost along the way. And I thought it might be interesting to look at some of those. Because some of the things that have got lost, it seemed to me, are actually, when you dig into them, are really useful functions. And then you or I become curious as to why they're not there anymore. So I got into this, I write, as well as lighting, I write. It turned out to be a useful thing during lockdown because you can still do it when shows are not happening. And then I hit upon this idea of this column called Classic Gear, which would look at sort of the history of interesting products along the way, products which shaped the industry, as I call it, which really means you can write about anything you like. 15 years now, unbelievably, we've been doing this, but I think what we learned from that is you'll never run out because the generations of products we have now will always be sort of slipping gently into the background. And as part of that, I also got involved with this group of people who titled ourselves very grandly the Backstage Heritage Collection in the UK. The main people of which are Jim Laws, who actually has a lot of this stuff in a barn outside his house, John Primrose, who collects it all on his website, and then a bunch of other amazing people who are just sort of always happy to answer when I throw random questions out into the ether. And this isn't a promotion for that, but just to mention what we're trying to do, the plan is, in an ideal world, to make a real museum, but that will never happen because of money. So is to try and make an online virtual museum where we collect as much of the information as we can about these products. That might be brochures, it might be photographs, but increasingly it might be the sort of memories and recollections of the people who made the products in the first place. Um, Information about shows that actually then use this equipment. So this is Cats, the original London production of Cats, which unbelievably is 40 years ago this year, which is all there on the Theatrecraft's website. So come and have a look. But be warned, if you have any interest in any of this, you will very quickly find your day disappearing. And then the last part is to actually, where we can, try and rescue the real products, the artifacts, the objects, the lighting desks, lighting fixtures, whatever, and put them in places where if you want to come and try it out, you can. So you could read about it online, you could read about how it was created, you could look at the specifications, you could find out where it is, and you can go and sit down. What I've learned through all of this is that real museums, because we've talked about trying to give some of this stuff to proper museums, they don't like you touching stuff. I don't mind. I want you to touch it as long as you're careful, because unless you can get like this particular lighting control, because this is a lighting control, not an organ, till you can get your hands on it and play around with it, you don't really understand just how amazing it would have been to sit behind and operate. So that's the sort of the concept of the day. I will warn you, this is like the warning section, there may therefore be some console nerdery ahead. That's sort of unavoidable. I hope that's okay. The accent probably tells you I am British, so there will be some unintentional British bias. There are some screen grabs and consoles. They don't necessarily say this is my favourite, this is whatever. They're just the ones that I had to hand or had the offline editors for or whatever. Not all of the products on show here today are made by Martin, and in fact most of them that we mentioned don't exist, aren't made anymore. So if you were coming into this expecting a sales pitch for the latest and greatest in lighting technology, then sorry, it's not what we're doing today. And I'll often say we wander through time in a quite non-linear manner, just because of the way that stories seem to fit together when I sat down to try and write it. So yeah, sorry about that. But to give you an example of the kind of nonsense I'm talking about, this you'll recognise. This is from an EOS, but most lighting desks have a similar function. It's a way of putting the shape of a fade onto a dimmer, so you can change the way that the light reacts to your control level in the console. Do you want it to go like that in a very linear way, or do you want it to go and then fade up, or do you want it to have a really slow start and then bloom in the middle? This curve here is interesting because it's, I guess it's what you call a preheat curve or a bottom set curve. So the numbers across the bottom are the level you see on your console screen. The numbers up the side are the actual values being sent to the desk. And what we can see on this one, and I'm pointing, you can't see that, I know that, but I'm going to keep doing it anyway. When you're sending have zero set on the console, you're actually sending about 5% output to the light. Sounds like a crazy thing to do, but it's useful if you've got noisy old-fashioned lights and you don't want them sort of ticking as the metalwork warms up. It's useful if you've got big filament lights and you want them to appear instantly when you start to fade. It used to be done a lot in rock and roll with park hands when you were doing chases and you wanted the light to appear instantly in the chase. So particularly a tungsten lamp, when it goes to zero and it's cold, the first bit of electricity just has to warm the filament up and get it going before it actually comes to life. It feels like the light is sort of hesitating and then suddenly bursts into life. So this would be a way of dealing with that. And we have the technology to do that, and all of them do now. The interesting question is, where does that functionality come from in history? Because, we've had light bulbs for a really long time, and probably this has been in memory consoles for a really long time. I guess on a manual fader desk, you could do it just by leaving the fader up a bit, but actually lots of old rock and roll dimmers had this functionality built in. But what's interesting is when you trace it right back, you find that there's a lighting technology where it wasn't just a sort of nicety that the light never went all the way off. It was an absolutely essential function that the light didn't go all the way off. So this is a gaslight. And gaslighting was used in theatres for quite a long time. But the problem is, and you had control, you could fade them up and down. That was their big technological advance over candlelight, which came before. So this is a gas table, I guess you could call it. It's a big main gas pipe with lots of outlets that would go off to different gas flames in different bits of the building. And they had taps on them, which are effectively dimmers. So you could now control the brightness of the lighting. But what you absolutely don't want to have happen is for the gas flame, when you fade it to 0, you don't want it to go all the way out, because problem 1 is you can't ever get it to come back on again unless you can go up with a flame and light it. So you need a way of making sure that doesn't happen. So if we do that, that's the dimmer. That's how you fade the light up and down. But if you look on the side of each of those pipes, there's another little tiny one, which I'm calling EOD preheat. And that's a bottom set. It's a little tap that would let a little tiny bit of gas bypass the dimmer, so that even when you turn the dimmer off, there was still a little bit of gas getting to the flame, and you would have a little tiny flame, but it hadn't quite gone out. And you could adjust that for the different flames and the different lengths of pipe, just to make sure that actually, when you faded everything to 0, the light didn't quite go out. Because as well as the inconvenience to the show when you're lighting, this used to happen quite a lot more often than it does now. The theatre's just bursting into flame. And gas, as you know, if you just let it go out to building, eventually there will be a spark, an explosion, and that will be the end of that. So getting your bottom set in the olden days, now it's sort of a nicety, then sort of essential. That's the kind of nonsense we're going to talk about for the next hour or so, I guess. We moved on from that. It's really interesting, actually, if you think about it in a sort of slightly quirky way, because it's easy to go, oh, well, we started using light bulbs. And what is a light bulb? A light bulb is a flame, same flame, but now encapsulated safely in a piece of glass. The other way of thinking about it is we, in entertainment lighting, moved from directly burning a fossil fuel in a really inefficient and dangerous and slightly unhealthy manner to using very safe, controllable, and now green, if you generate it properly, electricity to do our lighting. So basically what I'm saying is we were 100 years ahead of the car industry, which is now trying really hard to do the same thing. So every time somebody gives you a hard time for lighting being sort of non-green and non-eco and all of that stuff, which isn't true, but you should just remind them of that. Say, actually, we did this years ago. We should all just move on and stop worrying about it. It also meant is we could change to a new kind of control system. So now, instead of having to worry about gas, we could have electronic dimmers, and we had much greater control of our lighting. So we suddenly had big mechanical controls like this. You're turning levers or pulling handles to change the level, or what the rather dapperly dressed gentlemen are doing with those big wheels in the middle. Is each of those individual dimmers you can lock onto one shaft, and then you can crank the big handle and move lots of them at the same time. So you can effectively do fades of lots of dimmers without having to use lots of hands. Would have been really hard work, but you could do that. So this is Strand in the UK's Grandmaster from about 1931. Or in New York, where this carried on for years, I can't find a good photo of these now, but this is a piano board, which is the same concept, but sort of made into more modular sections for installing into a theatre. These ran Broadway lighting up until, unbelievably, the sort of late 1970s. Where we get into the then to now history of this is that even though they look nothing like the controls we use now, almost everything about the way we work lighting on almost all of the lighting desks, memory lighting desks we use today, comes back to these kind of boards because they're single preset boards, which means for each dimmer there is one lever that controls the level. And you move the levers to control the lights until you end up with a pretty state on stage. But the important thing is the lever stays there until you come along and move it somewhere else. Stays exactly where you've put it until you come along and change the level to a different level. And there's a word for that we use all the time now without thinking about it, which is tracking. Tracking is one of those things you can make incredibly complicated in your head. You can tie yourselves into knots about what it means. All it really means is when you put something somewhere, a channel, a level, a light in a position, a light in a color, it stays there until you move it somewhere else. Manual systems work like that because they couldn't work any other way. You just had the one lever and that was it. And what would happen is if you're running the show and it's manual and you have to write down your cue sheets with the levels, you would not write down the state of each cue. You would write down the first cue And then for the next cue, you would just write down the things you had to change. And then for the next cue, you would just write down the things you had to change. So basically, your cue sheets were a sort of running commentary on what you had to do during the show. It might not just be you, it might be a team of people. That was great for running the show. A lot of the problems we find in lighting technology is, though, not running a show. Running a show is not hard. Making a show is quite hard. Editing a show, changing it, is really hard. And so the problem with these systems is, if you're in Q1 and then you go to Q2 and then you're in a rehearsal and then the light designer says, oh, we just need to jump to Q10, the only way you've had to do that would be to work through each set of changes one at a time to end up with the final state. And people working on shows develop tools to help them to do this. So even though the guys, girls, probably guys, who knows, running the board would write their change sheets, the assistant to the lighting designer on a reasonably sized show would start writing down their own version of the cue sheet as well. And they'd be the one that took charge of going, we need to jump to Q10, so I'm going to tell you, I'm going to figure out the levels you need to be in for that cue. This is Vivian Leone, American associate. This is her old-fashioned, from the olden days, manual track sheet. And again, that's a term you'll recognise, where she's following on the level changes through the show. So that to jump to a cue, she could work back through the spreadsheet and call out to the guys how to get that state on stage. These are some examples from Ken Billington working as an assistant to Theron Musser, a remarkable lighting designer. He's doing it differently. What he's doing is translating the changes into a state, and he would call these track sheets for each cue. My favourite thing about these is he doesn't use an eraser. When he makes a change, he crosses it out and writes in the next instruction. And I started thinking of that as the sort of low-tech, paper-based version of what we would now call the undo function, because he always had a way of seeing how they got to a change. Even when computers came, this is a chorus line track sheet, the first memory board used on Broadway, they still wrote it all down, because here's the thing, nobody trusts, sometimes rightly, nobody trusts the new technology when it first appears. So even when these computers came along, this is LS8, which ran a chorus line, people would still write things down because that was like the ultimate fallback plan for when the computer went wrong. You could always go back to the paper. Just worth commenting, lighting always we always feel like, we're, maybe it's just me, we always feel like we're under budget pressure and nobody really appreciates what we do and nobody wants to pay for it. But when this went on to Broadway, first of all, somebody had to pay for this brand new computer technology. And then second of all, somebody probably had to pay to have the theatre converted to AC lighting to accommodate the thyristor dimmers that this had to talk to. So if you can make the case that your lighting is important enough, it turns out somebody will almost always pay for it, particularly if you're a hit show, it has to be said. Chorus Line or Hamilton, you can get whatever you want, or Phantom of the Opera back in its day. The other interesting thing we get from this, that's now a button, it's reduced to a button. So on the left is a typical layout of a Broadway piano board dimming system for a Broadway show. So each of the big rectangles is a dimmer bank. Dimmer banks 1, 2, 3, 4, 5, 6. Dimmer bank 1 is 1500 to 3000 watt dimmers. 5 is big ones for Sykes and things, 6000 watt dimmers. There's an auxiliary one on the top, which is for things like practical light. So that would run from one dimmer on board 1, and then you could choose which of the practicals you were controlling because you weren't wasting dimmers. And probably there'd be the E for electrician. One guy would be running dimmers 1 and 2. One guy would be running dimmers 3 and 4. One guy would be running dimmer banks 5 and 6. And if you look at the cue sheet on the right, you can see that there are 2 different times on this cue, the 8-second bit and the 3-second bit. So probably guy 1 knows he's doing his cue in 8 seconds and guy 2 knows he's doing his cue in 3 seconds. And that right there, that's the invention of part cues on modern computer lighting desks, where you split a cue into different timings. For part now, read electrician in the old days. Hey, you, Fred, you're doing it in 8 seconds. Except they wouldn't even call it 8 seconds. They'd call it 8 counts, which is like a second, but a bit bendy and flexible. Because the joy of having a human in the way is if they can see the show, because this is probably in the wings or in the basement, they could sort of bend time. If the actor's walking a little bit more slowly, they could just do the cue in about 8 seconds, but slowed down a bit. that sort of flexibility I miss, I have to say, a little bit in modern controls, where they all have rate wheels and things, but by the time you end up with incredibly complicated programming, it's sometimes quite hard just to go, let's just slow it down a bit. Or it's sometimes hard to empower the operator to say, just this is about what I want, but just spend time a little bit. And I think this is maybe a political statement, but it would be great to try and get a bit more of that back, I think. It is, after all, meant to be live performance and not just watching a movie. And we've all been doing quite enough just watching TV. So we need a bit more liveness to it. When computers kind of flooded in, the ones that wanted to be on Broadway didn't try and fight with the way lighting designers worked. Because the thing about tracking, once you get into it, is it's not just a function in the lighting desk, it's a way of thinking. This is Light Pallet, which sort of took over Broadway for years. Dave Cunningham, who created it, went into theatres, sat behind light designers, listened to the way they were talking to the electricians running the board, and just sort of encapsulated that into an electronic form. You know, the command line that you see on the Light Pallet and subsequent desks is just the electronic version of what the lighting designer was saying in the olden days, pretty much. But with the advantage that if you now jump to a cue out of sequence, the machine can do all that tedious work of figuring out how you get to that state. You know, the bonus in 1976 in this is because it was only storing the changes, just like the guys only used to write down the changes on their cue sheet, it needed less memory. And because memory was really, really, really expensive then, that also was a good thing. Just think about that there. We use this word cue completely interchangeably now without thinking about it most of the time. But it can mean two quite different things. It can mean what you're looking at, the state of Q2, or it can mean the transition that happens when you're in Q1 and you press go and Q2 happens. And sometimes in conversations, you just need to sort of make sure everybody understands subconsciously, I guess, that we're all talking about the same meaning of the word cue. It's interesting, though, how we very often just don't even think about that. But it's also interesting that we'll come to, historically, American light designers who've grown up in the tracking light palette world, a cue is always the change. Again, stereotype now, but British lighting designers who grew up on a consoles that were based on state, they think of a cue as the look. And where you mainly see that is American light designers, in my experience, spend a lot more time going to Q1, saying go, watching the transition, whereas British light designers are all about polishing the actual each moment by moment. And that's just an interesting difference that's come out of the way the technology evolved on the two sides of the Atlantic. The other interesting thing about the light palette is almost every lighting console we use for most applications today looks like a light palette. They all have the faders on one side or the other, but let's say the left, they have a set of keys in the middle, they have a wheel, they have two screens, maybe built in, maybe they have more now, but none of these consoles looks very different from the light palette. Left to right, if you don't spot them, we showed a competition, name the console. Light Palette 90 from Strand, Obsession from ETC, the Whole Hog 3 on the right, EOS, which is sort of a direct spiritual successor to Light Palette in a way, bottom left, the Grandma 2 and the Grandma 1. But yes, they all clearly owe something to the Light Palette. Interesting thing now about that handover period is when computers came and we were still writing it all down. What we would all now do is we would all merrily take that disk home and go look at it and work on it offline and all of that kind of stuff. That didn't exist in the early days of computers. You know, there was no offline editor for your laptop, probably because you didn't have a laptop, or for your computer, because that hadn't been invented yet either. Eventually they came along, but you still couldn't run this console software on your computer because it was written especially for that device. People always start making their own solutions, and I found this the other day, but it's a piece of software called ExpressTrack, written by Eric Cornwall, to try and solve this problem from Mac. This is quite a late example because it's in colour. The original one was on a black and white Mac, but you could not even load the show in from the light palette, but you as the assistant, instead of writing the information down on pieces of paper like we've seen, could, as the light designer was calling cues to the console operator, you could type the same command line into the Mac and it would sort of recreate the show. And then it would let you look at the data and analyze the data. And there's a nice little track sheet in the middle where you can see lights, how they run through queues. It sounds completely insane now, doesn't it, to have two people sitting away typing the same information into two different machines? But it was a step along the way to where we are now, I guess. Eventually, it moved on a bit, and it would let you bring in a disk from a light palette without having to do that. And now you just do it in the console. Another thing that carries on into the present day, you wouldn't write a queue sheet in the old days where you said 0, 0, 0, 0, 0, 0, 0. You'd write a thing that said fade all, so that you knew in that queue you had to make really sure that you got every single one of those dimmer levers down to 0, that you got an actual blackout rather than some stray light left on somewhere. And this still exists today. We just call it something slightly different. Oh, I missed an image, which we call block, where you say to the lighting desk, this is the end of this sequence of queues. That carries on. We call that a block queue. And track sheets, they're built in now. It's just a different way of looking at the data. It's a way of looking at the data sideways through the show. But that's how we've progressed through those generations of things into a function that we all just now use 100 times a day without even thinking about it. Or occasionally we end up on a console that can't do it. And we are cursing and swearing, going, why? Well, the obvious thing is we're saying, why can't it do this? I'm going, why have you not been paying attention to 100 years of lighting history and building in this useful function? It's an interesting thing. Some people ended up at the same sort of thing in a slightly different way. So this is the Verilight. The bottom is the Artisan, Verilight's second generation of desk. The top are the two, I think they're a VL2 and a VL4, so the early Verilight spot and wash light. Verilight was brilliant in a slightly crazy way of its day, because what they chose to do was not store any of the information in the lighting console. All the information about a queue lived in the lights. The lights had their own memory. And when you recorded Q2, only the lights that were on, so actually emitting light, would store the information for that queue, which again was about managing the amount of memory that was used, because memory was expensive. What that meant is if channel 10 wasn't doing anything for Q3, it just didn't know anything about Q3 at all, didn't know it existed. So if you jump to Q3, the lights that don't know anything about it will just not move. They won't even go to a position, whereas now all the lights would move, ready for whatever they were going to do next. And that's sort of a waste. These poor lights are working very hard as you're jumping around the show, even when they're not then coming on. So in some ways, the Verilight system was quite interesting. What that meant was, though, if you wanted to make sure a light was in the right place before it faded up, you needed to tell it to store the information about Q3, say, even though it wasn't on. And to do that, Verilight invented a special function that was effectively called active at 0 or on at 0. But what they actually called it was mark, which says, store the information you have now in this queue, even though you're not on. And mark, particularly if you're an EOS user now, will be a very familiar term, because that's the name that they've chosen to use to do a sort of similar function, not quite the same, but the function that says, automatically get the light ready in the right place for me. It's on the right-hand side, as I say to people learning the EOS, about halfway up. Here we have a really obvious bit of sort of trace the lineage, because the link is Anne Valentino, who was product manager for various versions of the light palette Strand. Then she went to ETC and helped create the Obsession. Then she went to Verilight and helped create the Artisan, which was the Virtuoso, which was the successor to the Artisan. And then she went to ETC to make the EOS, which has this mark function. So, you can follow the path very obviously. Because the EOS is the sort of meeting of the traditional conventional light world of light palette Obsession and the moving light world of Artisan Virtuoso. Through all of that, the last interesting thing is that tracker word just takes on a different meaning. It was the assistant writing down the track sheets, and then it became the assistant writing down the numbers for when the computer went wrong, and then moving lights came, and it became the assistant who was writing down what all the moving lights were doing, particularly when early consoles couldn't give you that information very well. So that job title just keeps on and on and on, but just evolves slightly over the years. Okay, so jump back in time slightly, I guess, in our weird passage through all of this. All of those other boards we've looked at, the early ones, have one thing in common. The keyboard, and then next to it, that level wheel, which is another thing that we probably don't even stop to consider in our daily life nowadays. Clearly, I've been in lockdown for too long, and I've spent too long considering this. Because prior to that, again, as we said, it was real physical interfaces. There was a lever per dimmer. Or if you were a cunning marketing person, this is a little strand board they used to sell in schools called the Junior 8. And it's brilliant marketing because it has 8 sockets on the bottom, but it only actually has 4 dimmers, those 4 faders in the middle. But then there was switches, and you could decide whether that was controlling one socket or both sockets, or each one separately. So it's a marketing gimmick, but it makes it sound better because 8 is obviously better than 4. Tracking, as we saw, came from that. It also meant you were at the dimmer. You were right there. It was really hot. It was really difficult to operate. You probably couldn't see the stage. You were probably you were probably on stage next to the action of the show. That would have been fun, but not seeing the show would have got a bit tedious over time. That's not necessarily a limitation of a mechanical system. To give you an example of what you can do if you have the money and the inclination. This is an installation which was, until very recently, not in use, but still installed in a theatre in Lausanne in Switzerland. So this is a Bordoni dimmer system. So in a control room, on the left, you have the faders, like you've always had. You have the crank handles, like you've always had. But instead of these being part of the dimmers, they're now driving this big mass of steel wire ropes and pulleys into these auto transformer dimmers, where the steel wire ropes are lifting transformers in and out of themselves to make the fade. The fact it's still there and you can still make the things go up and down is kind of a testament to an amazing piece of engineering it was. But it was a first step. The British version, you had motorized dimmers in the basement. So the dimmer wheels on a shaft with a clutch that was electronically controlled to decide whether the wheel was turning that dimmer or was releasing that dimmer, and you could use that to control levels. And these systems are sort of interesting because they're halfway in between the mechanical dimmer. When you move the dimmer, you're changing the level, and what we have now. Because on here, what you could do is, if you turned off the motor that was driving all the dimmers, you could set the next level on the faders, but nothing would actually change at the dimmers until you pressed the button and all the motors started running and the fade started happening. And that is very much sort of like you can do now if you're in blind, or if you're particularly on a grandma, if you're in blind programmer mode, where you can make a change and then have it appear on stage, particularly if you remember to set the fade time so it doesn't happen like that. So it's an interesting example of a completely different technology imposing a completely different set of limitations. But it turns out that's actually quite a useful limitation, because now you could start presetting cues ahead of time. You started the motor with your foot. It's a bit like driving a car. If you look at the bottom of this console, there are some foot pedals down there. So a slightly different set of skills from the ones we sometimes have now. Electronic dimmers came, and this is progress, because now you can just put the faders wherever you want and you can control them without being anywhere near the dimmers. So the gentleman on the left is at the National Theatre Old Vic in the 60s. You can see he's in the auditorium because you can see the theatre box around him. And what you would now have the ability to do is to have multiple sets of faders per dimmer. So on bank 1, preset 1, preset is another word that gets reused over and over again in lighting. You could set Q1, have it live on stage. You could have Q2 preset, crossfade to Q2. Now you can clear bank 1, set Q3. Or if you're fancy or have more money, you can have 3 presets, so you can be 2 cues ahead, or you can have 4 presets and become 3 cues ahead. Some big American systems were like 8 preset systems, which is slightly crazy. And people got used to working like that. They like the direct access to anything. And that was a challenge when computers came along, because the people who made early computer controls felt sort of honor bound or marketing bound or something to provide that same interface. You weren't going to be considered a real lighting console unless you had 120 faders for a 120 fader system. So this is IDM, Instant Dimmer Memory, which is also called MegaKey, I think, in America, from about 1965. So it's a single preset, but you still have 1 fader per dimmer. So you could still set states exactly like you always had before you then stored them. In a slightly different market, rock and roll was the same approach. You wanted to just be able to grab those faders and play with it. So this is an Avo Diamond. Back in the day when they used to have cabinet makers handcrafting the woodwork around them, and then leaving their label. This guy I discovered now makes really, really beautiful high-end kitchen. So, you know, if you want a kitchen with a bit of rock and roll heritage, I can give you his phone number. The problem is, I mean, there are lots of problems, but the principal one is, if you've made a state and you record it, store it, and then you go to a different state, none of the faders move. So now, what you'll see on stage doesn't match what's happening in your faders. And if you touch a fader, you're not quite sure what's going to happen. As with everything, there are solutions. So this is a Siemens console from, I think, the 60s or 70s, where it was that system, but because it's German, all those faders were motorized. The Germans don't mess around with things like this. However, equally, Siemens is not in the lighting console business today. So I think it probably didn't work out well for them in the long term. But it would have been an amazing thing to operate. Everyone else had faders. And the other thing you get into then is this same problem of, if you make a change, so editing again, how do you say, I've only moved one fader, I only want to store that, rather than restoring the whole state of all these faders, which is wrong, which is an incredibly familiar problem today that different people deal with in different ways, but is the basis of the programmer concept in the grandmas and the whole hawks, that when you make a change, you only store the stuff you've changed, not everything else that happens to be on the stage. IDM had a similar function where you could, all those, the levels between the faders were illuminated in different colors, and they were also switches, so you could push them down to match the level, say, oh, what level was it at? Okay, that's where it was. And then there was a function you could use to say, just store this change into the memory rather than re-recording the whole state, which is sort of like update or selective store or store merge that we find on consoles today. The other problem is, though, you know, as you have more dimmers, the console gets bigger and bigger and bigger and bigger. Eventually you need a wheelie chair to get from one end to the other. So people tried to find solutions. This is DDM, Direct Digital Memory, from Strand, about 1971, where instead of faders, which were expensive, they put rocker switches on it. So you pressed up to make the light go up, and you pressed down to make it go down. I mean, it sounds terrible to me, because you'd never be able to control the speed. It would always happen at whatever speed you'd preset somewhere. You know, you could never do it quickly or slowly. And faders also give you an instant feedback of the level everything's at. This didn't have that. So it didn't really last very long. The eventual innovation, the thing that's shaped everything we do to this day, is this thing, which is called Qfile, from about 1966, made by Thorn, who were a lighting company who sort of got into entertainment lighting through television. And the big driver for all of this in Britain was the arrival of commercial television, and the arrival, which meant more TV studios needed equipping than just the BBC that we originally had. And colour television, which meant you wanted or needed more precision on lighting levels so that you didn't mess up the very sensitive colour cameras. They also had more money than theatre to pay for all of this. So Qfile, all those faders have gone. And what we sort of basically have is what we have now, which is a numeric keypad for selecting the channels, and then a device for controlling the level. The numeric keypad doesn't quite look like we expect it to look today, because instead of having the calculator style numeric keypad, it's a column of numbers like you used to find on a cash register or an old-fashioned adding machine. So this Qfile, you can tell without looking at the brochure or reading the specs, you could only go up to 99 channels, because that was the biggest number you could type. Then the real innovation on the right, so if you wanted more channels, obviously you had to get a bigger desk, so that would be a 299 channel version. On the right, though, is the interesting thing, which is there's this single fader for controlling level. But the trick is it's a motor fader. So now when you select a channel, the motor fader jumps to that level, the level it's already at. You can see what that level is, and then you can adjust it, and then you can decide to store or whatever it is you want to do. Again, it sounds so completely obvious now. Sorry, that's the numbers and that's the motor fader. But it was an innovation of its time, because now what you're doing is, instead of you going to the channel fader over here somewhere, you're bringing the channel to you, and then you're making the adjustment, and then you're storing it. it wasn't a computer. It's easy to think it was a computer, but it wasn't. It was a custom-made electronic machine that did lighting control, and it didn't do anything else. You know, aside from that pretty little console, there was this set of electronics to make it all work. There was a theatre, you know, it came out of TV, but eventually theatre adopted it because it was the first sort of reasonably priced, sort of reliable memory control system in the UK. You could tell the difference because the TV ones were called Studio on the record button, and the theatre ones were called Stage. And the theatre ones seemed to have more channels. And it was sold in the UK, in the US by Qfile. So the historical footnote here is this is the desk that Fred Foster, who founded ETC, the late Fred Foster, found a Qfile at his university, was really impressed by what it could do in terms of lighting, discovered it had cost his university $250,000, give or take, went home to his brother, who was a computer scientist, and sort of spieled off about it. And his brother said, well, you know, I reckon we could do that for $5,000, because what had just appeared then was the original Intel microprocessors. And that's what they did. They made this product, it's called MegaKey, which was the product that launched the company that we still see today. Didn't have a motor fader though, just saying. The problem is, because every evolution comes from something in history that then hits a problem and then has to sort of twist to work around the problem. So the problem with that motor lever, which is really clever, is what happens if you select a group of channels and they're all at different levels? Because eventually the fader is going to hit full, but the other channels won't have reached full yet. So how do you then keep them going up? And the solution, which somebody thought of, and it sounds obvious, but until you think of it, it's not the obvious answer. You know, WYSIWYG, it sounds really obvious, but somebody had to think of it. Was this, the level wheel, a continuous controller, so you can just keep wheeling it. There is no upper limit, there is no lower limit. If you have a bunch of channels, they'll all just keep going until they all hit full or they all hit zero. Strand's engineers, Strand were the first people to do this. They admit that they were inspired by a console that we don't have a picture of, but it had controls very like this, which is the much later Martin Maxis, with these flat belt controllers, which is the same thing. It's a continuous encoder, never stops, no beginning and no end. But what they didn't like about the belt encoder was that it was flat, whereas your hand naturally falls into a sort of curved position. They thought the wheel was a more comfortable way of doing it. And what they were actually basing that on was the quadrant fader they used for their earlier generations of manual consoles, which I still think in good nick, when it was new, is one of the most comfortable, intuitive control devices for lighting ever. Because it's sort of, you could put your hand on it, it followed the curve of your hand, and it was really comfortable. It was, yeah. So what you will never have realized is the wheel is the same shape as the quadrant fader. You tend to think of it as half the wheel sticking out of the console, but it's not. It's only about a quarter. The rest of it is down like the iceberg in the bowels of the machine, making it all work. And the last bit is, on most consoles, if you have a light at zero and put your finger at the bottom of the wheel and you wheel it up until your finger hits the case again, you'll have taken the light from zero to full, because that's exactly the travel that you would have done with one of those faders. Again, nerdy aside, nerd alert. But in the old days, when you coupled all these dimmers onto a shaft, what happens when you wind the shaft and they get to full is they all get to full at different times, but eventually they all end up at full. And then when you wind the dimmer back down, they all now come back together. So you lost all the separate levels they used to have. And that Strand on their consoles would call shaft mastering. Whereas nowadays, what most computer consoles are smart enough to do is they'll all come up to full from their different levels, but it will remember how far offset they were. So that when you fade them back down again, they all come back down at different times and retain the proportion of those different levels. But a thing that has been lost lately, I've noticed, is the choice about how your wheel behaves doesn't always exist. Whereas it used to be able to say, I want my wheel to behave like a shaft, or like what they would call proportional mastering. Interesting aside number two, it appears that, as far as I can tell from extensive Googling, Strand never patented the level wheel, which is why it's now everywhere. Whereas some other people are now a lot more protective about little inventions they make. So like the keyboard cover on the grandma consoles is patented. even though it doesn't feel entirely different from that little slidey cover that we used to find over the keyboard on the light palette. Okay. A little pause and think about what we do also quite a lot of the time. We turn lights on, we flash them around, we change the levels. Sorry, that was a mess. Back to the wheel. Yeah, so hold on. Oh yeah, so I was going to touch on this. MMS, the other thing you'll have noticed is we've now changed. The column keypad's gone away. The numbers are there. We now have what we now think of as this sort of calculator-style keypad. But what's interesting there is there are two choices. You could put one bottom left, which is how computers do it, or you could put one top left, which is how telephones do it. Nobody in my little collection of Strand engineers can now remember why they made this decision. David Cunningham, who went on to make the light palette, his first go at computer controls was this, which was called CompuSet 2000. And what's interesting is he did it the other way up. But then when he made the light palette, he flipped it around and put the one bottom left. And I think, somebody will say I'm wrong, but I think that's now the way all computer consoles do it. And that's just because it's the way computers now do it, and our brains are now sort of trained to think of it. Okay, so after we mess with our lights, eventually we're going to want to turn them all off, turn them all down, start again. And we could do that. You know, we could, particularly on a memory board, we can select them all and wheel them all down. But the more convenient way is the function that we've been given, which is called now Remdim, which is a function that says, the light that I've got selected, keep that on and turn everything else off. Funnily enough, if you have a console where you have to write a macro to do this, that's exactly what it says. Store the lights that are on, select them, turn them off. Oh, sorry, store the one light you've got control of, turn everything else off, leave that light on, and then clean yourself after yourselves. Where did that come from? Because, of course, the reason it's there on computer boards, you don't need it necessarily, because it would be almost as easy to type 1 through everything at 0. Select all, wheel it down. But on the big mechanical boards, that wasn't true. Because on the big mechanical boards with the big mechanical motorized dimmers, you would have to select all the channels that were at levels, and then you'd have to select the level to 0, and then you'd have to run the motor, and then you'd have to watch them all go back down, and then you'd have to select the one light you wanted on, and you'd have to turn it back on again. That's harder. I'm not quite sure this is where Remdim came from, but this is the earliest example I can find. And also, I just love showing pictures of this because it's insane to think of this as a lighting control now. But this is Light Console. Made by Strand about 1935, went all the way through to 55. They were still running in London in a few theatres in the 60s. Strand Lighting's head engineer, who was a guy called Fred Bentham, had this pet obsession of his own called colour music, which was performing light to music on a stage full of objects, which is what we would now think of as rock and roll lighting, or particularly with the static objects, it's almost trade show demonstration lighting. But this was Bentham's obsession, and that was really hard to do on the big mechanical consoles. So the amazing thing he did is he created a lighting control to satisfy his own obsession, and then he persuaded the world to buy it to fund its existence. You know, there's a certain amount of cunning involved with that. It was based on the organ, I think, partly because he wanted it to feel like a musical instrument you could play rather than a mechanical lighting machine. And also on the very practical ground that the company next door to Strand in West London were the Compton Organ Company, who were sort of the British version of like Wurlitzer in America. So they made all the big church organs and all the big cinema organs. You could get big ones. So the one on the left is the 240 dimmer Theatre Royal Drury Lane version. Or you could get little ones. So this is the 60 dimmer or something, 40 probably dimmer Bristol Old Vic system. The gentleman standing on the right of the right-hand picture is Fred Bentham later on in life. This, I think, is sort of the start of, you know, families of consoles, isn't it? The big console, if you've got lots of money, or the little console, if you don't have much room or much cash. It operated the same motor-driven clutch dimmers. So now you've got these beautiful, beautiful banks of selectors for deciding which lights you're controlling. And then you run them up and down by pressing the foot pedal and the motor starts. But there is no way of setting a level. The only way of getting a look back is to be watching the stage, know what you're looking for, and as the thing starts feeling right, is just to deselect things from the motors so that those lights land at that level. It's kind of amazing to imagine now. With your feet down underneath, like driving a car, running the dimmer motors up and down. But if we look closer down there, and we look over on the left, you'll see that there's two buttons, foot pedal buttons, called Remdim, which is Remdim by another name, which would say, make everything black out, and I think blackout is immediately, so it would basically disconnect all the dimmers, or dim, which would mean fade everything down apart from whatever channel I've got selected, so the start of the next scene. And it's right there, it's Remdim by a slightly different name, but exactly the same function from 1930. Some really big, really serious shows got run on these consoles. And the key to it, and I think this is still true now, is that it's the talent of the person running the machine that ultimately wins, however clever the machine is or thinks it is. And that's still true even with computers. We have user manuals for this machine, so if you want to come and figure out how the hell it works, you can. They're on the website. What we don't have so many of is the cue sheets for this. Here's one we have about how you describe the cue. And it's, the lighting designer who left the show to an operator would put an awful lot of trust into them to keep it looking the same, which has to be said is ultimately why Light Console was replaced by other control systems, because lighting designers became much more fussy and protective about what their shows looked like. Interestingly, aside, so this is 1969, Dave Cunningham again. I should have said Cunningham, if you don't know it, is the genius who, I don't suppose you'll mind me saying crazy genius, but genius who has his hand all the way through our history with some very commercially successful / game-changing products, because he invented the light palette for Strand, he invented the CD80 dimmer for Strand, and then he set up on his own. We invented two products, one of which was called the sensor, which is everywhere, and one of which was called the Source 4, which really is everywhere. His first attempt at computer control, 1969, at the Anomaly Factory in California. Similar sort of thing, trying to store data, punched it to tape, but he added a second interface, which is not unlike Light Console, which is a piano keyboard, effectively. And again, it just imagine being able to play lighting, because an interesting thing about Light Console is those organ keys were too force touch sensitive. You could push them a little bit and that did one thing, and you could push them harder and it did something else. Imagine if your submaster buttons detected how hard you pushed them, and you could sort of do your flashing show with a level of sensitivity like that. The harder you pushed it, the brighter the lights got. That might be interesting. Now would say it should be called record. People who use theatre desks like the ETC desks, MA people will say obviously it's called store, because MA have decided to call that button something slightly different. Interestingly, neither of those two words actually fit with the whole storyline that the light palette and all those computer desks learnt by listening to what the lighting designers were saying and evolving the words, because the lighting designers then would have said things like write that down or plot that or something. And those aren't words that we use now, really. Interestingly, the first sort of memory-ish control didn't use any of those words either. It used an entirely different word, and it used the word punch, because this was a thing that was officially called KTV from about 1959, and everyone knew as Clunk because of the sound it made, because how it was storing your cue was by punching it onto a punch card. It worked. You could sort of store looks, but interestingly, Strand in their next generation of consoles, when they sort of had to talk this one down, suddenly started admitting that actually, while it was good for storing cues, it wasn't so good for editing cues or jumping around the show out of order, working on the show, because suddenly you would have to shuffle all these paper cards into different order to get to the right cue. And of course, jumping around cues, editing like that, is actually what we spend most of our time doing in tech. At trade shows, console people will tell you that making cues is hard and their console does it better. Making cues isn't the hard part. The hard part is when you come back to edit the cue later on. By the time of IDM, which we saw earlier, MegaKey as it was called in America, this word record had appeared, and it was on a big round button, which is nice, circled up at the top, yellow, color-coded so that you could find it, which is another thing that's sort of gone away over time from lighting consoles. Interestingly, if you talk to the Strand engineers of the time, none of them can quite actually remember where this word came from, why they chose the word record. Possibly it came from the audio industry, cassettes recording onto tape. Possibly it became because where this actually stored its cues was onto a memory drum, which is a hard drive that's sort of the size of your desk and about the height of half your body, but actually had less storage capacity than your watch. You know, and it was an amazing thing. We have one we have the one that belongs to this IDM, and you can, I mean, it doesn't work in the sense of getting data, but you can turn it on and it makes a most incredible noise, like a sort of aircraft taking off. So somewhere along the way, this word record appeared. Nobody can quite remember why, but interestingly, Qfile also used the word record. CompuSet, which is one of the first consoles, memory consoles made by Dave Cunningham again, also used the word record, except he separated wing record, which was, I guess, storing from the faders, versus stage record, which was storing the whole state from the stage. So, which is a bit like, I guess, we'd call selective store now. Galaxy carried on the word record. Strand and most of the theatrical style desks since then have used this word. Other desks, MA, were very cunning in their use of the word store rather than record, because what that made very clear is that if you were expecting this function to do what old theatrical desks did, which was to record the entire lighting look on stage into a memory, that's not what store in an MA typically does. Typically, it stores only the contents of this thing that they call the programmer, so like the editor, into memory. And that's exactly the same as the Compulite consoles did, which I think used this programmer concept first. And they also, I think, used the word store. And the whole hog does the same thing, but it confusingly calls it record. Again, a lot of the sort of confusion about lighting control when you're moving from one console to another isn't necessarily about the actual functionality of the console. It's about the words they use to represent the same functions, or sometimes the same words they use to represent different functions, which in some ways is actually more confusing. Galaxy is really interesting. I discovered just while preparing this talk, never knew this before in all the years of using these consoles. So the Galaxy was Strand's sort of top-end lighting control in Europe from about 1980 to about 1993 or 4. Really popular in theatre, really popular in television studios, to the extent that they kept on using them long after they weren't manufactured anymore, because they felt the replacements weren't as good. The detail I've discovered, and I could prove this because I had a prop. I bought a prop, I bought a bit of Galaxy, which is, my children now use it as their Millennium Falcon targeting computer. But the factoid is that springs behind the record buttons up here, color-coded in red, so they're easy to find, are double the strength of the keys of any of the other buttons. So every time you go to press record, you get this sort of tactile reminder that you're about to do something really serious. You're about to record something, or record over something. If you were going to record over it, it would also beep at you, and you have to press again to confirm. But I would almost bet nobody who's used a Galaxy has ever really known that's there. But as soon as you know it's there, as soon as somebody told you, and I went and tried it on my Galaxy Wing, as I call it, it's completely obvious. So it's this little tiny detail, which is actually completely brilliant. That's how I think we ended up with record. Along the way, the other thing that was happening is these machines were getting more and more complex. They were adding more and more functions. We flash back, we've seen this console before in our sort of out of timeline meander through all of this stuff. This is MMS, which we saw earlier, which was the first console to have the wheel. MMS stood for Modular Memory System, because the concept here was you could specify the bits of the console you wanted. And not only that, but you could arrange them physically however you wanted. So if you were left-handed, you could put the channel control stuff over on the left, maybe. If you had a little theatre, you could squeeze it into a smaller space. If you had a bigger theatre, you could add more, and more money, obviously. You could add more modules and make the whole thing bigger, make it spread out. You know, interestingly, I always assumed growing up that you could just move things around once you had the console. But in fact, it was sort of custom built to exactly your specifications. So Strand would send you what they called playing cards, like life-size cardboard versions of each MMS module, so that you could experiment with laying them out in your control room, decide which way you wanted it. and then you put your order in, and they built that console for you. You couldn't move it around because all the wiring looms had to be really precisely calculated lengths to make all the electronic timing signals within the console work. So once it was built, you couldn't change anything at all. Interestingly, even though MMS had this keyboard, numeric keyboard for controlling channels, selecting channels, so bringing the channel control to the operator rather than you having to go to a fader, Strandword thought there might be some people, old school users who would prefer a control per channel, like a fader, but without the expense of a fader. So they offered this module on the right hand side here, the channel module, where there's an individual button for every single light in the rig. So I think this is a 120 button array, and then the wheel. So now you can select a light, adjust it, deselect it, select the next light, adjust it. Probably you could select multiple lights by just clicking, and there would have been some logic for how you dealt with that. If that looks familiar to you from another generation of console, it's probably because you have some recollection of this, which is Verilight's Artisan console, Series 200 console, so their second generation of lighting control, which ran the first generation of big moving light shows, and it was an incredible machine to use because every single one of those buttons on the face panel was backlit, not with an LED because it predates that, but with a real light bulb. So I mean, A, it looked really impressive and you felt really cool standing there using it. But B, particularly if you were doing an outdoor gig, it would bring cooling air in the back and blow it out through the face panel. So if you're outdoors that night, you're in this little warm bubble of air heated by all these light bulbs, which actually was quite good. Wasn't so good inside in a hot theatre on a summer's day. But the other interesting thing about the Artisan you'll notice is all the encoders for the moving lights are over on the left, and on almost all consoles now they're sort of in front of you or to the right. So I'd always wondered if somebody high up in the Artisan team was actually left-handed, and that's why it was done like that. 100 buttons, so one per light in that big square up the top, but then to the right of that are a set of page buttons. So now you could select 10 pages, I think, 1, 2, 3, maybe 20 pages. So 1,000 or 2,000 lights. And when this console was made, that was more Verilights than actually existed in the world. So it was a sort of demonstration of their ambition and where they thought their system was going to go. And ultimately, the Artisan did end up controlling some really, really big rigs of Verilights. That continued into the Virtuoso console, the successor to it, where it was a separate module, so you could move it to wherever you wanted it to be. Theatre people will probably point out that the MMS is obviously better because it's a 120 button array and not just a mere 100 button array. LSD Icon users will point out that they had a similar thing on their console, but with very fancy buttons where you could individually have digital labels on each button, which was really expensive, but obviously really quite cool. The thing about both those desks was you couldn't buy them; they were only rental, so the company could invest a bit more in them, I guess. As well as encoders on the left, you'll notice those flat encoders, which are sort of what we use to control moving lights to this day on almost every console, even though it's slightly counterintuitive, particularly to be controlling tilt using an encoder that turns clockwise and anti-clockwise. As the functionality continued to grow, consoles were big. As we'd shrunk down from these massive desks with hundreds of faders into these smaller spaces, but now it felt like everything was growing again. This is the Whole Hog 1 console, the original Whole Hog, and on the right you can see it with an Artisan having a sort of size face-off about who's bigger and more impressive, with a sound desk actually in the mix as well, going, well, I'm bigger than you and I've got more faders, so I win. It's interesting that it was like an arms race. You added more encoders and the lights got more functions. You added more pallet select buttons and suddenly you have more palettes. You added more anything, and the lights and the users and the technology demanded more stuff. It could have gone on forever. Or what you could do is stop and pause and think and reinvent everything from scratch. And that's what the team behind this, the Whole Hog, and then this, the Whole Hog 2 console, so the Flying Pig team did in the early 1990s, where they said, instead of trying to have a button for every possible function, we have to accept that whatever buttons we have, somebody's going to want another function later on. So why, instead of doing that, why don't we replace all those buttons with an interface that uses touch screens and then the interface can change to suit what you're trying to do at any moment. And it can also change if we change the software and we add more functions later on. So we can always add capabilities to the desk. Nils Solderson in particular, who was one of the team, will still describe this to you as the sort of burger fries approach to operating lighting, because it's very much like you find in a cash till in a fast food joint when you place your order and they just have a touch screen to pick what your order is. I sort of jokingly say that on some shows the lighting desk should come with a credit card slot on the side so that you can make the producer pay per queue as you do your work to deliver the show. But I've never really got anybody to buy into that idea. Sort of as I think we've learned all the way through this talk so far, we think this is a revolutionary breakthrough that the whole Hog 2 ushered in, but in fact it's not. The Hog 2 is about 94, 95. This is a console from 1987, which is called Oscar, which was designed by a team, or inspired by Tony Catelier, and built really for nightclub lighting. So big light shows over dance with music. But again, you needed just to be able to get access to lots of looks and lots of things and select the lights really quickly. And the team behind it came to the same answer, except being those few years earlier, they didn't have flat screen LED or LCD screen technology. So the reason it looks so bulky is because behind there is a real old-fashioned cathode ray television set with a touchscreen layer over the top of it. But it worked, you know, and again, there are a number of these sold and they did great work. Oscar, the name, comes from the Russian dolls hidden inside one of each other, because it was like more layers of functionality hidden away inside the desk. But of course, even that actually isn't as original as you think it is, because a decade before that, a bit more than a decade, Steve Skirpan in America had made a range of lighting consoles which didn't quite use touch screens, but they used a light pen to let you touch onto the screen. So you couldn't just use your finger, you had to use a device, but you still had this thing of being able to directly select channels and then manipulate them using the controls on the desk. You know, interestingly, the Vista, Jan's Vista, when it came along, also had a pen, so not entirely dissimilar. It was only later when iPads appeared that I think we all rediscovered the joys of just being able to touch things rather than having to have a pen or a pencil in the way. I also find it interesting along the way to imagine what would happen if you could take different bits of technology like this and other things and sort of merge them together, whether you would get something amazing that we've missed out on along the way. So I always wonder in particular about this. This is my what if console. So this is called the Premiere from a company called Electric Controls in Canada, possibly. Somebody will tell me if I'm wrong. And its trick was that if you look in the mirror, in the middle rather, there's what looks like a transparent screen, which is a half mirror of the same kind you use for teleprompters or auto cues. So now the deal was that you could have the information about your rig floating in front of you, and then you could have the stage behind it. So you weren't, as sometimes ends up happening on big shows, at the console with this wall of monitors in front of you, and you can't actually see what's happening on stage without sort of having to go like this all the time. It's really clever, but I wonder what would happen now if you could take a WYSIWYG or other visualization software is available, obviously, a previs software, and put it onto that screen and line it up so it aligned from your point of view with the real stage. And then you would be able to really quickly identify what that red light over there was. Or even better, you'd be able to reach out and touch it on the screen, select the real light, and now directly manipulate the real light on stage. That, I think, would be a fascinating sort of merging of all these different technologies. The closest to get to that, I guess, is the fancy GPSs you get in fancy cars where they project your route onto the windscreen in front of you. But to have that in a theatre, I think, would be really interesting. And the other thing is size. Again, Hog 2 shrunk everything down. Now size seems to be making a dramatic comeback. You know, this is the Grandma 3, which is, whatever it is, 2 years old now, but the big one is really big. This is the new Avo Diamond, which they launched a few days ago. Well, a few days ago before we did the first version of this, and so 2 weeks ago from doing the second version, which again is also a big, impressive console with lots of quick access to everything, including a little extra screen at the top because they're trying to integrate media control properly. Size still matters, apparently. Who knew? Okay, right, shall we talk now about the thorny subject of colour? It's like the new frontier in lighting. It's the new thing that we've always assumed is a really obvious, easy thing. You know, you cut out a piece of coloured plastic and you stick it in front of the light and you get that colour on the stage. You don't really have to think about it other than whether it looks nice. Or then moving lights came along with their usually 3-colour colour mixing system, and you had 3 encoders, and we all got the hang of sort of doing subtractive colour mixing. So you know, that sort of worked. It's become more complicated now that we've got all these multifaceted LED lights where you might need lots of encoders. But you know, we sort of got the hang of doing it, and touchscreens again gave us the ability to get to lots of colour choices quickly if we had to. This is from an EOS, it happens, but showing you a colour library based on the Roscoe swatch book. Because again, we're at a really interesting time where there's a generation of lighting designers who still think in colour in terms of Lee and Roscoe colours or plastic gel colours, Apollo, anyone else, GAM. And there's a set of up and coming people who have only ever used LEDs who have no notion of what any of these things mean. So it's an interesting transitional period. And also interesting because if you've made the colour, you know, the thing about Lee 201 is it will always look the same. You've got to reference what it is. If you just mix a bit of colour on somebody's lights in some theatre, the interesting question for you is how you make the same colour in the next theatre with somebody else's make of moving lights. And that's the sort of challenge, I think, going forward. This isn't also new either, obviously. This is the software that ran David Hersey's light curtains. Digital light curtains were moving past strip light from about 1990. The control software ran on a Mac. It was a 2-directional control system, so the lights could talk back to you, which again, we're only just getting back to now. And you had a little pop-up menu where you could tell it what the colours were. So you didn't care necessarily that it was frame 6. You knew that you wanted Roscoe 03, and you could go pick that. Brad told me this, I didn't know this, but the high-end Status Q console from about 1993 had a very similar function and also had a colour picker, which clearly doesn't work so well in a black and white screen grab, but the same thing where you could notionally pick colour. Now, what they hadn't done, the hard part, I don't think, is actually calibrate all the lights to the console. And this is still a problem with colour in lots of ways. You would get an approximation of Roscoe 71, but it wouldn't really quite be the same. And if you care about colour, that's important. So, you know, so we're sort of getting there. None of that's new either, because if we go back to the 1930s, what we discover is this, which is a thing called Cromlux. This is Strand's version. There was actually an earlier version made by a different company, and it ended up being an example of a patent war lawsuit between the companies because the other guys thought these guys had ripped them off. So what this was designed for is if you were doing a cinema or an ice rink or a dance hall or something, and you didn't have like a full-time lighting crew, but you wanted to be able to change the mood of the room to suit whatever was happening. So it was a box with a big knob and you could choose a number of predefined colours. And the colours were made because overhead in this space was probably a line of compartment batten floodlights with gels in them, which could have been red, green and blue, or it could have been red, green, blue and a tint, could have been some other set of colours. But the manufacturer, Strand in this case, knew what those colours were and therefore knew how to mix them to make these other colours. So this was connected to the big mechanical clutch basement dimmers in the basement, just like Light Console had been. But instead of you controlling it manually, when you turn this, it's set up a predefined lighting state and the lights would fade to the different colour. And in a big room, you might have different zones, as you'd now call them in a hotel or whatever, ballroom lighting rig. So you had different zones here. In fact, you can see from the labels, one set is for the footlights, one set is for the overhead battens, and one set is for the dips, the lights in the floor. But yeah, Clunk, turn the switch, off you go, a different colour would fade in because these are mechanical dimmers. They can't go quickly, even if they wanted to. But this is LED lighting and colour libraries in consoles now do, but, you know, nearly a century ago now, I guess, 1930s, 1940s. It's pretty remarkable. And this, we believe, actually got involved in, was brought up in one of the early patent disputes about LED colour mixing by people trying to say, this has been done before. This is not as original as you think it should be. So colour added all this extra complexity, and then we've been adding tools to deal with it. Moving lights added even more complexity, which we sort of tend to think of now as Varilights in the 1980s. But in fact, moving lights go back much further than that, because since the 50s, people have been taking big theatrical spotlights and sticking some kind of motor on them and then wiring it back to a lighting desk, where almost you were controlling pan on one fader and tilt on another fader. And getting the thing to ever go back to the same place would have been really hard. This is the latest generation. This is the VL2, one of the earliest ones. This is the Martin Viper, I think. Viper, can't tell if it's a spot or a wash, but a Viper. Dealing with that on, first of all, fader desks and then traditional theatre lighting desks would have been quite hard. It would have been juggling numbers and writing things down, because all the tools we now use to deal with this, preset focuses, palettes, all of those things hadn't been invented. So these are some manual paperwork for dealing with that. On the left from Chess in New York, which is 1987 or 88, I think. In fact, it says at the bottom, 1988, if I look. So manual notation of the pan tilt values and then what the light's actually trying to do. Aspects of love, they clearly started doing it in some kind of computer system, but it's the same thing, which is a manually written record of 640, 271, and what that actually means, where the light's actually pointing. What all of this really needed was some kind of sensible control which integrated all of this stuff together and made it part of the lighting console, rather than a separate device and a separate set of paperwork to deal with it all. Varilight did it, of course, in the 1980s with the Artisan, but it had been done before that. And it had been done in the early 1970s, and it had been done at the National Theatre in London, which opened in 1976, but it opened late because the building overran. So all the design work on the consoles and control systems and theatres were actually done in the late 60s and early 1970s. So this is the Olivier Theatre, the big 1,100-seat theatre in the National, under construction, with its very famous drum revolve elevator system, which makes up the stage halfway down and probably stuck, because, you know, otherwise I think there wouldn't be a ladder resting there. One of those gentlemen in that picture is Richard Pilbrow, lighting designer, but also theatre consultant for the National. Top right is the slightly more completed Olivier, and then below that is the part of the rig that they put into the Olivier, which was designed to deal with the fact that the National plays in rep. So it might do a show in the afternoon and a different show in the evening. It might do a rehearsal in the morning, a show in the afternoon and a different show in the evening, and it would repeat that every day of the week. So there might potentially, in the original plan, be a different show performing every night. So you wouldn't be able to change an entire rig around between that. So the theory was they would put in enough lights that there'd be a sort of comprehensive cover rig, and then a series of specials that you could have per show, and then a very few lights you could refocus. But then over the stage, which was incredibly high and hard to access, they put in a rig of moving lights, which were 2K strand Fresnels with a motorized yoke made by either Pani or Technic, one of the German Austrian companies who were a bit ahead of the game in equipping German theatres. And that was 1976. But they didn't want it to be a separate box controlling it. So as part of the specification of the lighting desk, Richard Pilbrow, a lighting designer now getting to specify a theatre, decided now was the time to make his sort of ultimate dream lighting desk. So he wrote a specification. And the specification was everything he'd always wanted to be able to do. It was to be able to control multiple groups of lights. It was to be able to have lights running in different times, because nature isn't just one fade. Nature is things coming and going. And that really hadn't been possible up until then. It was about the lighting designer being able to interact with the lights if they wanted to, rather than having to dictate commands to an operator. And it was about having integrated control of the moving lights, and also the color changes the theatre had, which was semaphore fold in, fold out color changes, and also slide changes on their projectors. And also, just for this massive rig, the Olivier had 800 dimmers at a time when the average was probably 100 to 150 dimmers in a theatre, in a big theatre. 800 dimmers to cope with this big permanent rep rig. This was presented to a number of manufacturers, and Strand ultimately, who I think was still a bit grumpy about the success of Qfile in television, Strand decided to have a go. And they built this, which all the way through the design process was called TCS, Total Control System. When it was actually launched as a commercial product, somebody decided that name was a bit hyperbolic and over the top. So it became known as Lightboard. All the early National guys still refer to it as TCS. Some of them still work at the National, which is kind of remarkable. And what you'll see in TCS, if you look right down the far end and you click on the little description of what everything is a thing called orientation control. And that's the moving light control right there. And it was a panel and it had a wheel, just one, but then it had 3 buttons called pan, tilt and focus, which was all those lights could do. They could move, and then you can make the beam bigger or smaller by, like Fresnel, moving the bulb backwards and forwards behind the reflector. So you had to choose what that wheel did. So you pan it and then you tilt it. And that sounds really awkward now, but these lights were quite slow, I'd imagine. So probably that was okay. But there's a generation of British lighting designers who went through the National of this era who will still refer to moving lights as PTF lights, pan, tilt, focus lights, because of this control panel on the light board. They will now, the Strand engineers who built this will now, it's interesting. The one thing nobody will tell you is how much this amazingly advanced lighting control system of its day cost, because everyone seems to have conveniently forgotten, which makes me think it must have been really expensive. What they will now admit is that this moving light control wasn't quite as well integrated as they would have liked it to have been, because they started building it in 1969 and they were told it had to be delivered by 1972, which it was when the building was meant to open. They say if they'd known they'd have had another 3 or 4 years until the building actually opened, then they could have integrated it properly. But nonetheless, it worked. It let you control these moving lights. It let you use them in shows. And in fact, when the National came to replace the light board, so after about 10 years, you could no longer get the spare parts for the PDP-11 mini computer, which actually did all the thinking. So they replaced it with a Galaxy. Galaxy at that time didn't have moving light control. So the National Theatre lighting team engineered their own replacement moving light control using a PC and a load of custom interface cards so that they could carry on using their moving lights. Now, I promised I'd talk about not just things that have carried through time and the history of them and all that stuff, but also about this sort of interesting things that have got lost along the way. And so if we just zoom back to the wide shot of Lightboard, the other thing that you will notice if you look is that it's got not just one level wheel like most consoles now have. It has multiple sets of wheels. So on the left, there's a set of 4 wheels. And then on the right-hand side, there's another set of 4 wheels in a sort of separate little bit of the console. This, to my mind, is one of the most amazing things of this console that is a mystery for me, why we no longer have this functionality. Because on all current consoles with their one level wheel, you can only make essentially one adjustment at a time. You've only got one channel controller. So you can select a channel or a combination of channels or a group of channels or whatever you want, and then you can adjust them. But as soon as you've done that, you have to make another selection and adjust it, and then another selection and adjust it. And even if you want to immediately go back and adjust the first set again, you have to reselect them all. And if you want to adjust 2 things just to balance the look on a cyclorama or something against each other, you can't do it unless you start selecting channels and assigning them to submasters and then having to deal with the submasters and the fact that they're faders and how do you record them and what then happens. And it's just incredibly complicated. Whereas very often what you want is just to be able to grab us some lights, grab some other lights, and even as the lighting designer, not the programmer or anybody else, just play with them. Just like you used to be able to do in the olden days when you could grab a bunch of faders and physically manipulate them. Lightbulb was designed to let you do that. So the two sets of wheels, the black wheels on the left and on the right, were called pallets, not as we now know the meaning of the word pallets in terms of moving light reference groups, but as a way that when you could select a bunch of lights and assign them to a wheel, then you could select another bunch of lights and assign them to another wheel, and select another bunch of lights and assign them to another wheel, and then you could just mix with them. You could mix your look on stage. You could do that in the control room. What you couldn't do with this console is move the whole thing out into the auditorium as we do now, because the main part of it was too hardwired into its big microprocessor. And also, having now rescued one of these from a skip, I can tell you they're quite heavy, so you wouldn't necessarily want to do that. This is the specification as produced by Strand for the thing. That's the actual module on the right. So you have a channel control with one level wheel, but then you can assign the channels to the other wheels. But the right-hand module, which is called the Pallet, you could lift out and take down and put at the production desk in the auditorium. So now if the lighting designer, so on the right is the right-hand gentleman is Andy Phillips, lighting designer, or if you just want to play, so this is David Hersey's son actually playing with it on the left, you could manipulate the light, or the person running the console in the control room could manipulate the light, or you could share, or you could take it in turns, or you could play and then tell them to record stuff. And it became, those who used it at the time tell me, a sort of magnificent collaboration in light, rather than just feeling like a lighting designer dictating numbers to somebody else. Incredibly clever, but that's not the cleverest part of it. The cleverest part of it is that if you made that look and then you recorded the cue remembered what was on those wheels at the moment you made the cue. So that later on, and again, the hard part is editing the cues. When you came back to edit the cue, it might be tomorrow, it might be next week, it might be next month, and if you're doing a big show that repeats around the world, it might be next year or in 5 years' time. When you ran the cue, the way the cue was built, building blocks appeared on the wheels in front of you. And so instead of having to do what we do now, which is, I'm in a theatre, I've got a cue up, the cyclorama's too bright, now I need to figure out the channel numbers for that, so now I need my plan, or I need my magic sheets, or I need an assistant to tell me, or something to then select it, to then bring it up. It's right there. The wheel says psych, and I can just make the adjustment and re-record. That's an amazing function, and it's an amazing achievement if you bear in mind that this console had 64 kilobytes of memory, not megabytes, not gigabytes. It had less processing power than your watch, even if it's not a fancy Apple Watch. You know, it was really borderline that this thing could actually deal with the number of dimmers, but yet it had this incredibly useful functionality that I think it's really sad has gone away. Because it's really easy to imagine how useful it would be now. You know, if we do a mock-up where you said, okay, I've made my cue and what I've got now is the red backlight, the blue cross light, the psych, and the head high cross light. Whereas at the moment, however you made the cue, groups, submasters, faders, channels, the moment you press record, it disintegrates into 100 channels or 1,000 channels or 2,000, or with big LED rigs, 10,000 channels. And you, every time, have to figure out all over again how to bring it all back together. Given that computers now have sort of infinite power and infinite processing, I think that's insane. I do wonder why the National, this happened, and I think it's because they almost overnight moved from their original theatre, the old Vic, which was 120 dimmers with that manual console that we saw earlier, to the new National Theatre with the 800 dimmers, the moving lights, colour changes and everything else. So it was a sort of multi-order of magnitude change, and they knew they needed tools to help them deal with that. Whereas all the rest of us have gone, I've got 50 dimmers, I can deal with that. I've got 70, I can deal with that. I've got 100, oh, okay, I can deal with that. I've added some scrollers, okay, and that's a challenge. Okay, I've added a few moving lights, okay, I'm figuring that out. And we've sort of along the way learned all the tricks and things that we need in order to deal with that stuff. And the consoles have got a bit better, but we've learned the workarounds. And we very rarely in the middle of a show have time to stop and sit back and go, why am I doing this? The machine should surely be able to help me do this. It's very rare that consoles radically reinvent themselves. You know, as an example, this is a piece of software called LampTramp, written by Wayne Howell, who also invented ArtNet. He's in the picture on the left. in about 1992, because on the Pink Floyd tour, they wanted to do writing on these big arrays of light bulbs, effectively, not LED again. And the choice was they could have sat there doing it channel by channel, but Wayne, being smart, thought that's crazy. What we should do is just have a thing where we overlay a graphic on the screen and the screen figures out how to map that to the lights. And that's effectively what we would now think of as a pixel map, or to some extent a media server. And it's gone from being a separate piece of software to being built into, in some form, almost every console you know. But somebody had to go reinvent it and prove why it was useful. Whereas it's very interesting that the channel display on any console, but this is an EOS as an example, isn't really very different from the channel display for the LS8, the memory desk that ran a chorus line in 1976. You know, it's channel numbers and levels, and okay, now we've got color and boxes, but actually there's not really very much difference. Occasionally there is a radical reinvention. So this is a screen grab from Vista. Vista was the most amazing console when it came out because it tried to do everything in a timeline. So you could just do queue timing by dragging and rearranging and reshaping rather than having to do lots of complicated syntax. It really broke the mold. People who use it love it, and yet it's, how you would describe it, not one of the leading products in lighting control because it's a really high learning curve, because it's actually a different way of thinking if you're used to the way the older consoles work. The other thing you could do with the same thing is what I call smart groups, or maybe like if you had the if or query functions on Grandma and EOS, you might call it like dynamic if. So instead of you having, you're looking at the stage and you're going, I need to select the red lights. How do I find them? The machine should surely be presenting that to you. You know, the dot gobos are too bright. Which lights have got the dot gobos in? Okay, I use query, but what am I querying? Dot gobo, whatever. The machine knows all that, and it should be able to present that to you, I think. And then you would immediately be able to grab it and select it without having to do lots of hunting for things. Okay. Anyway, rant over. I've been ranting about this for years. Nobody's done it yet. If you're a console manufacturer and you'd like to do it, call me, we can talk. So sadly, time is flying by. And there's so many things we haven't even touched on. So maybe we can do those next time. So maybe we can do things like mathematical wave shape effects, which have saved us from the tyranny of having to do lots of programmed step chases. Started with, I think, MQ on the ProSpot desks, but then the Hog turned it into sort of mathematical shapes. Except interestingly, I hear the MA3 is adding a function to do old-fashioned step chases, because sometimes actually you can't beat them. We might talk about reference palettes as a way of storing position data. We might talk about XYZ programming, which is now coming, so that the console actually understands that the lights are working in 3D instead of just as pan tilt values. But then we might talk about, you know, Flying Pig and Avo and others for years have been trying to do devices which you can put on stage and they'll wiggle your lights around and figure out where they all are actually, so that you don't have to make a sort of deadly accurate 3D model, which you can never do because the truss never ends up in the right place. And we might talk about voice control, which the Starlight moving light console in the mid-90s could do. And which I now think of every time I hear my 10-year-old telling her Alexa to turn on her Hue light bulbs in her bedroom, because lighting is everywhere now, which is kind of amazing. So there's so many things, but let's just finish on one, which is like a comedy one. So the lost late night function, which was a button on the whole Hog 2 called Instalook. And Instalook is kind of, it's very representative of the sort of insane, mad, unconventional brilliance that was everything about the Hog 2, the Hog, and then particularly the Hog 2. Because, you know, the Hog came out of doing like raves and lots of late night shows where it didn't necessarily matter what the look was, as long as something happened. That was important, was the change. It didn't really matter if it was that shade of green or that shade of green. So what Instalook was created for was that thing late at night when you've been plotting something all day or working all day or just making cues and you've just hit the wall and you've just run out of ideas and you just don't quite know what to do next. And what Instalook would do was not generate a random lighting state, but it would take whatever you had on stage and it would just mess with it a bit. So maybe it would do a range of colors around it, or maybe it would move the position of the lights a bit, or maybe it would change the gobos. It would make a look, and if you pressed it again, it would do a different version, and you could just keep doing it. And it was kind of brilliant because, I mean, if you were really desperate, those cues sometimes ended up in the show. You know, sometimes you'd go, oh, okay, that looks nice, record, in a slightly embarrassed way. More often, it would just be enough of a jog for you to go, oh, purple. Oh, I never thought of that. That looks nice. Okay, now I'll mess with it, make it a bit better, and then I'll record it and move on. So it was clever enough to give you a little jog and let you do it. At some point, and I've been trying to find out when, and I can't, it went away. Obviously, somebody decided it wasn't serious enough for a serious lighting desk, and it went away, and I'm not sure it's ever come back. But it would be really good if it could, because it was great fun. Or what I really want, I've always wanted in the lighting console, and I hope somebody will do, is what I call the at better button. So, you know, you've got a cue on stage and it's not quite as good as it should be. You can either polish it forever, or you just go 1 through 50 at better, press enter. The machine would fix it for you. Bada bing, we're all done. That's the function I really want. So whoever does that first gets my vote. Okay, there endeth the vague meandering history of some random bits of lighting control, I guess. So yeah, thanks for listening. If anyone's, well, originally I'd have said if anyone was still awake, questions, but in our fake reshoot version, we have some of the questions from the real version. So hit me with them.
We do, and Rob, thanks again for doing this. This is extremely fascinating, and as you'd mentioned, we had some technical difficulties, and we had to re-record about the second half of the session. But as you mentioned, we do have some
hair moves. Yeah,
we do have some questions that came in during our live session, so we'll kind of just get right into that. How difficult would it have been to transfer from a rocker switch system or something like that to a Qfile?
I mean, which I think is sort of memory to non-memory to memory. I don't know. I mean, I think it's like anything, isn't it? You know, you learn, and if a new tool is presented to you, you sort of go, okay, this gives me advantages. I mean, the thing I should say that I meant to say at the end of all of that, and I didn't, but I'll say it now, is fundamentally, it doesn't matter how good the control system is, how clever it is, how many buttons it's got, faders, how big it is, small it is. The thing that makes it work is the person sitting behind it, operating it. You know, we haven't yet got to the stage where you have the lighting desk and then it just does the lighting. And I don't think we ever will. You know, and there were amazing people working all those manual systems back in the day, but they just had a different set of tricks and skills and things that they needed to deliver it. I mean, I think the interesting related version is that in preparing this, I talked to Ken Billington about some of the Broadway history stuff. And I said to him there, the interesting question is when they had to move from the big manual boards to the memory boards, particularly on Broadway with the union thing there, you were potentially going from 4 guys being employed to run the show to 1 guy being employed to sit and press the go button. And that's obviously 3 less guys being employed along the way. And I would have expected to be resistance to that. And Ken says actually there wasn't, because the advantage of the memory control stuff was so compelling that as soon as they tried it, everyone was like, okay, well, clearly this is the future and we just need to figure out how to deal with it. I've then since read something about the original chorus line where the guys were like, we can do it on our old-fashioned stuff, we'll prove it. And Farron Musser, the light designer, did a fake session where she sat down, made some cues and then ran them to time. And by the end, the guys were admitting, it's like, oh my God, we can't, okay, we give in, we can't do it, the computer wins. You know, but then computers didn't do very much. Now we're back to this thing where even with a computer desk, you're not manipulating 120 dimmers anymore. Chorus line was 96 dimmers, I think. You're now dealing with, you know, 200 moving lights, each of which has 20 parameters. And you're dealing with 300 dimmers. And you're dealing with LED lights where each one has 10 parameters because they can change color. And you're dealing with a media server, which has got hundreds of channels. And you're dealing with a giant LED video wall, which might be another 10,000 parameters. So as the console helps us, the task of what we're doing gets more complicated, and it's sort of this loop of trying to keep up, I think. So yeah, we're always having to learn the new tricks.
Yeah, and it makes sense. You touched on throughout the session some of the things you'd like to see in the future of console. So what do you see or would like to see as the next big advancement in the interaction between console and operator?
I'd like them to be smart. I'd like the console to be smarter, by which I mean, not like scary artificial intelligence, but have a better understanding of what it is you're trying to do. So the thing I was talking about with the light board is it drives me crazy that, even on this picture here, if you could still see that, there's a load of channels there, but you've got no idea what any of them do or how they're used. If I go 1 and 3 and 5 and 7 at 50%, what I'm effectively doing is telling the machine that those channels are related to each other. I'm using them together, and I genuinely think it would be useful if it could remember that. So that when I then go 2, 4, 6, 8, 10 at 50, and those are simplicity examples, but it remembers those. And then if I want to adjust the first set of things again, I don't have to select them all over again. They're just right there waiting for me, and they're there waiting for me in a year's time. And it baffles me why people who make consoles haven't bought into that. And I have this slight suspicion it's because there's a sort of a multi-step process between the lighting designer who's trying to create this thing on stage and the people who make the consoles, most of whom are software people rather than necessarily theatre people. And there's now a set of people in the middle, so like the programmers in the middle. So the lighting designer says, here's an example, I've got a red set of lights coming this way and a blue set of lights coming this way. And it looks beautiful, but the sunset's coming from the other side now, so I need to just swap them around. That sounds like an incredibly simple thing to do, but it's actually incredibly hard because you have to store, you can't just even copy these colors to here because now you wiped out these colors. So you need to store these colors in order to be able to, it's like a 3-part exercise. But that's a thing you need to do quite a lot. So there should be a function in the desk that says this set of lights and this set of lights swap parameters, swap color. And if the lighting designer talked to the software programmers to explain what they were trying to do, that might be what they get. But what actually happens is they talk to their programmer at the desk. The programmer does a load of number crunching that's like, take this, store it here, take this, copy it here, take this, store it here. And what they go to the manufacturer and say is, I need a better way of doing this 3-step copy. And the manufacturer never understands that what you're actually trying to do was this. I think there needs, if there was a closer involvement between the designers who ultimately these machines are there to serve, and the people who make them. I'm not saying the programmers well. In the future, if you imagine the Minority Report version of a lighting desk, where instead of a programmer person, you had like 2 things that stuck onto the lighting designer's head, and what they thought was magically transported to the stage. That's sort of the job the programmers actually doing. But it's like describing how the better tools you need to achieve that job, I guess.
Interesting. Here's another one. Why were key switchers common on controllers and now not used at all?
Yeah, I don't know. What we mean by that is the big old mechanical proper, the keys, you could lock the desk and then take the key out and take it away. I think they're probably not there anymore, partly because they're expensive. I think they're not there anymore because on those old systems, if you lost the key, you were a bit stuffed. And I think they're not there now because everything is software based, so you can't have software mechanically move a key. So if you need to be able to unlock the desk remotely from the other side of the theatre or somewhere else in the world, you can't have a big key switch there to do it. But I miss them because there was a sort of security in just actually going lock and take it away, and now I know nobody can mess with it. So yeah, maybe they should make a comeback too.
Interesting. Here's another one. Any idea, with the early Verilights, how many cues could each fixture store?
No, and because this is a reshoot, we asked that question first time around, and if I'd been smarter, I'd have remembered and gone and looked up the answer. I think there is no answer. I mean, the interesting thing about that is because the light was storing the cue and was only storing the cues when it was on, you couldn't even necessarily say, if it's 1,000 cue show, it will fit, because each light would have a different number of cues because it only cared about the ones that was doing something. So I'm sure there is a number. I don't know what that number is. I do know that they did some really big, impressive shows with those systems, so it must have been a fairly reasonable number.
And last one, it's kind of a fun one. We talked about it on the first session, but if you could go back in time to work on one show, what show are you working on and why?
I can't remember the answer I gave last time. I don't know. I have this complete fascination with, as you might have gathered, with the National Theatre light board. And I think I would really have liked to have been in the control room at the National Theatre when they did the first show with it, having gone through all the trauma of getting the building open. Eventually they moved into the building before it was finished, because otherwise the builders were clearly never going to finish. And I know the person who was the board op for that, which is what they call programmers then, for that show. And what he says is he remembers doing the show, and then he remembers Richard Pilbrow, who designed the thing, and David Hersey, who lit it, both running into the control room like overwhelmed with joy, because I think they'd become so worried that they'd made this control system that was incredibly brilliant, but maybe too clever and maybe too overcomplicated and maybe too technologically advanced and really borderline cutting edge technology. And he said the sense of relief when we delivered that first show and it all went without a hitch. David Hersey will tell you the story of some time later when it failed during the show, and as well as the lighting desk, you had like a pin patch behind you in the control room, so you could put little pins in to electrically connect dimmers to a set of faders, and then you had to run the whole show manually on like 24 faders. That would have been a whole different challenge. But I think to see the light board actually doing what it was designed to do with the people it was designed by, that would have been a pretty amazing day out, I think, in my time machine.
Excellent. Well, Rob, that's going to do it. We really appreciate you presenting this session and also doing the re-record as well. It means a lot. Thank you to everyone who watched this session. This recorded version will be up on our YouTube channels and our training portals here in the next few days. And please be on the lookout for all of our future sessions and make sure to register and check those out. So thanks, everyone, and have a great rest of your day.